Okay, so I think we're live. We're live. And we we stopped yesterday, last stream, in this to do. We have to make a function that gets x and y integers coordinates from the cell and the outputs one-dimensional index. What I mean by that is if we run our example, we want something that because what we have here, we have a grid, and this grid is a two-dimensional grid, right? So it has x's and y's coordinates, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and so forth. But in memory, this is an array, a linear array, and one-dimensional array. So we need a function to convert this two coordinate system to an index, one-dimensional index of the array. That's what we need. We kind of already have this because I do this. I do it exactly here. So it's just a matter of putting this in the separate function, and that should be it. That should be do the trick, right? So we can already try to do that. So it's an index. So we want an integer as output, and I'll say that the name of this function could be. Let me open the chat here just real quick. Okay, and a good name for this function could be maybe transform 2 to 1, no, get, or maybe calculate one dimensional, maybe just calculate index from chords, something like that. And the coordinates will be a vector, vector of integers. Maybe, yeah, maybe just int x and int y. That's it. And we just return this. We just return this thing here. Like that. We can do like return, but x actually is j, right? X is j, so this is j, this is x, and y is I. That's it. So let's think for a moment. If we have, let's think about it. We have several x's. So it's x times this quantity, one time, two times. So it's x, so this is x quantity of x times y. One time, two times, three times, right? I mean, no. Plus y. And y, yes, plus y. I'm not sure. Y times, yes, because y is this number, grid cells quantity x. Yes, so 1 times this is 1 times 1, 2, 3, 4, 5. 5, 10. Yes, 10 plus x, which is, yeah, I think it's correct. I think it's correct. So here I just call the function. I just call the function here, calculate coordinates, and this is, oh my god, this is always like that, huh? It's J and Y and I think. So let's compile. Return grid and the, oh yeah. We don't have grid cells, so maybe we can put like x quantity as an integer. Then we can just pass this like so. And then here just do this. This is a utility function. We can put it in other place later on. So let's make this. Okay, it should be working. Make. Yes, so fine. Okay, so what we have here is we have some initial values for the cells. Maybe what is interesting to do is to click here and maybe show the values of this cell, because for each cell we have a structure for the cell. Examples, grid plug H. We have if the cell is active or not and the temperature value. So let's do that. Let's click on the cell, identify which cell we are clicking on, and taking back its values, its properties. Maybe we can do that on, this is a cell, this is a grid action. This is a grid action. Yeah, this is a grid action. Okay, yeah, let's just put it here. We will return cell, not a pointer, but their values, and this is get cell, and we have to pass the grid a pointer to the grid. We won't modify it, so yeah, grid, and the mouse coordinates maybe. Yes, if we have access to the, maybe we can pass the position, but we don't have the cell position. Maybe, yeah, the mouse coordinates, like, so get cell on mouse, not on mouse, but below mouse, below cursor. Get cell below, this is really weird. Cursor, below mouse cursor. Whatever. Let's just do it. Then maybe we get the vector 2, which is the mouse coordinates. get cell, just get cell. Then we pass the mouse coordinates. Because with mouse coordinates, this is from coordinates of the grid, but we do already have grid coordinates, which return to us screen to I vector. We have I vector to grid coordinates, which is screen to grid, and we need floats, which we do have, and the plug. That's annoying. We need the plug. So we can solve that later. Plug. We need the plug. So we just pass this. We just pass mouse coordinates X, mouse coordinates Y, and plug. And I think plug is, yeah, it's not a pointer. Then we can use this function, calculate index for coordinates, and we pass the same thing. No, not the same, but we pass the grid coordinates X, grid Y, and maybe another thing, X quantity, which is always the same, which I have in plug dot what it's called, it's a grid dot cells quantity X. Yes. Then we just get the cell. We can return plug, right? Yes, plug grid. I think we have plug. We have access. No. Plug. It's not a pointer. Plug grid cells index, right? Yeah, grid cells index. Yes, index, like that. Then we have the cell. So on update, when we click with the mouse, if on mouse, this is mouse button pressed, the left button, and is over, and I will do like grid. I think I have plug is a pointer. Yes, it is. Plug grid. If both are true, is over. Then we just get the cell, which is get cell, get mouse position, and the plug. I think that's it, right? We don't need grid, no, just mouse coordinates and the plug, because grid we already have here in plug. So here is plug dot grid, plug dot plug grid. Yes, that's it. Plug, yeah. So I think we have this. So we need to create those functions. I mean, this is over. But for now, let's not do that. Let's comment this out. Let's do that later. Let's just test. Okay, so we get the cell and then we just print trace log info. And then this would be float, which is temperature, and temperature, and if it's active or not. Active, which is D. And here is cell dot temperature and cell dot active, like that. So let's compile. And let's go through the compilation errors. Grid has no member name it X. Of course it's not. It's grid. Yeah, it's grid chords. Grid chords. It's not chords, it's chords. Chords. This is grid chords and grid chords. What else? Grid has no name X. Where is it? I need to save it, then compile. Vector vector 2 has no members, cells quantity. Yeah, but this one says this is plug. This is one was correct. This is plug grid cells quantity X. I think that's it. And plug get cell. Get cell needs, oh, of course, because it's a pointer, so we have to dereference it. And the next error is the same thing. No, yeah. Make. All right. So let's see if it's working. Temp 0, it's not working. HDYN, 50, yeah, here is working. 100, yes, 0, no, it's not working here. So 50, 100, 50, okay. It's almost there. It's almost there. 50. It's almost there. Interesting. Interesting. So we can maybe we can check what's wrong. Grid coordinate, screen to grid. This is working. We checked that. So we get the grid coordinates from the mouse coordinates. Yeah. Then we just calculate the index from coordinates. So let's print this. Is T D and is grid coordinates X and grid coordinates Y. Let's compile. Let's reload it. And let's check here. Okay, so 1, 1, 1, 2, X and Y. X and Y, right? X and Y, yes. X and Y. For some reason, I think maybe we are changing. Maybe we are get mouse position. This is X and Y. First X, then Y. One, 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 two. Yeah, it's correct. It's correct. 1, 1, 1, 1, 1, 2. Calculate index from coordinates. Yes, it's correct because it's working here. If I invert this, it won't work. You see? Yeah, so that's correct. That's correct. So if that's correct, this index is also correct. So this means that we have an index of something, which I'll check here. 6, this is not correct. 6, 7, 8, 9, 10. 15. The index is not correct. The index is not correct. This should be 1. This should be 1. Oh, of course, because it begins with 1 there. Yeah. Yeah. It doesn't start with 0. Yeah, so this is -1 and -1 there. It's -1. I mean, I can just do I can just do y means this and this. And I need to put a comment here, like I mean, not here, but when I am calling it. When I'm calling it, because here it starts with 0, it's correct. But then when I call calculate index from coordinates, this screen to grid doesn't start with 0, it starts with 1. So I have to put -1 here. I mean, not here, but here. 1 and -1. Yes, like that. And now it will work. Maybe it needs a comment here, but never mind. I don't think so. We can just compile and check that. Okay, so 50, 50, 100, 50, 50, 50, 50, 50, 150. Perfect. And all of them are active. Terrific. Perfect. That's what I want. That's what I wanted. So we did that. We don't need this trace log anymore. Trace this, delete this. Okay, so we need to make this plug grid is grid is over. It's over. We have it's over. It's over. I think we have this function in somewhere. Tag is over. Yes, we have here. We have the position, the size, and it's in MyCGUI. Yeah, perfect. We already have this. So we have to have the position and the size. We have to have the position and the size. Where is here? It's over. So this is position grid. Now remember the .h file. Examples grid.h. Pause position and grid dot. I don't have the size, but I can calculate. I'll put here grid size, which I can calculate. Here is a vector 2 grid size, which equals to maybe I put this outside. Yeah, the thing, the update function. So the size for X is plug grid dot position plus the quantity times the cell size. And I have cells quantity plug cells quantity dot x times cell size plug cell size, like that. And the same goes for y. Cell size the same. Okay, so it should work, right? It should just work, I think. Yes. Let's compile. Okay, plug has no member called cells quantity. It's grid. Okay, of course, it's grid. Plug grid dot, and the same here. Grid dot make invalid operands to binary. Yes, with pause dot x and here is dot y. Okay, in place declaration is overrid. Unused variable cell. I just need to go back with the trace. Where's the trace? Here. So I just do this and return everything back. Put it there. Make. Of course. Okay. So let's go there and check if it's working. If I click outside, nothing happens. Click within, one, yes. 150, 100, okay. Perfect. If I do that, it will, yes. Okay. Good, 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 good. Okay. Maybe I'm not happy with this being calculated every time. Maybe grid size. Maybe this is global. But I don't have plug. I don't have plug outside. I mean, maybe I have plug. No, I don't have. This is just the definition, not the initialization. So this is being calculated every time, and it's maybe if I put static, I think it gets calculated just once. Let's see. Test. I'm not sure, maybe not. I think it doesn't work like that. Void value not ignored. Let's see. What? Oh, yeah, of course. How do I test this? Let's ask. In C, if a static variable is declared inside a loop, it will be calculated at every step. I mean, there's a iteration, or just once. I think it's every iteration. Creating the story on each iteration, it just so happens that it gets created every time on the same, yes. However, these variables contents getting preserved across loop iteration will be in point B. The non-static, okay. Okay, let's see what this say. If a static variable is declared inside a loop, it will be initialized only once during the program execution. Initialized, specifically in the first time the relation is encountered, in subsequent iteration, especially the first time the relation is encountered. In the subsequent iteration of the loop, the static variable will retain its value from previous iteration or call, yeah, and will not be, okay, it will not be reinitialized, but it will be recalculated. Okay, so static int counter. Okay, loop int counter is 0 and counter plus plus. Yeah, of course. Loop function, and okay, and it retains its value. It retains, but I mean, yeah, I see what it means. It means that it will be created in the same address. That's why it's retained, because the address of its creation is static, right? Yeah, I don't know, but how can I do to take this out? Grid size. In it, because it's only executed once, but I have to maybe create a new grid and grid size. I really don't like that. So inside of grid cell size, I can put float int grid size. I mean just size. Grid size and cell size. Okay, so position and size will be like here, and cells. Okay, maybe those two there. Position, size, and the rest is cells, and this one can be in the end. It doesn't matter. Yeah, it doesn't matter. This is a pointer. Okay. Yeah. So size. I just put this vector 2. Size is vector 2. Size is vector 2. The grid size is vector 2. Yes. Then where do I say position? Grid position here. I have position cell, and then I can do size x. It will be something, and size y. It will be other thing. And I can go down, and it will be this thing here to the end, right? So I can go there, go back there, up there, and just do this. Then I can go back and delete this, because now I have grid size. Like that. Then we just make, and I think it's missing now. It should work now. Perfect, but it's not working. That's terrific. Yes, I know. I think I know why. Let's pay attention to this. Grid position I have. Cells, I don't have cell size yet. cell quantity, yeah, so I just need to put cell size first. Here. That's it. So this is plug, 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 plug. Yeah. Yes, now it will work. No. Yes, this is X. Good. Let's run it. Perfect. 150, yes. So everything is working. Even if I do this. Even if I do this, I can still check the proper values. Of course. So size must be recalculated if, yeah, that's interesting because init not is never created. Okay. Okay, so if I do this, yeah, because yeah, I see. So this should be recalculated. Yes, this should be recalculated. So I can do this. I can do this. Because we change the size, then this doesn't change, this doesn't change, but this changes. So yeah, we need to recalculate those. So if I make and rerun it now, yeah, then I change back to 10, apply. Now only here, it's working only here, doesn't work outside, but here still works. Down here, yeah, somewhat close. It works still. Don't know why. Okay, whatever. If I put 100, yeah, sometimes, yeah, somewhat close to clicks here as well. We can check this. This is a bug. This is a bug. Okay, so we did some things here. Let's check what did we do. Let's check the diff. Okay, we are calculating index from coordinates. Then we are getting cell, yeah. Getting cell properties. Properties and not add, get is a properties is good enough. Okay, so we did some things in 44 minutes. Yeah, I think we did some things. I really like this. So next time we will try to make those properties appear here. So we we will make good use of this thing, and maybe I won't call it debug anymore. It will be a cell property window. Maybe I create a new container with this information. This will be just a debug that we can start hidden, and then we just click on the hotkey so it can be shown. So yeah, I think next time we can do that. So bye bye.